In this video, I'm just going to briefly introduce some terminology of free versus bound indices, just so you know what people are talking about when they use those words. So in a tensor expression, all of our indices are going to be classified as either free or bound. They're one or the other, not both, not something else. Those are the two ways we can categorize them. So bound indices, these are repeated with one up and one down, and so they're summed over. Free indices are not summed. All right, so let's just do some examples. P, mu, rho, a rho. Let's do a tensor product where there's a contraction. All right, so we have two indices here. We have mu and rho. The rhos are repeated, therefore they're going to be summed over. These are bound. The mu is free. All right, again, all of our indices are going to be classified as one or the other. All right, in this expression, we have four different indices. They're all different from each other. None of them are summed over, so these are all free indices. What about now all of our indices are repeated, right? We have this mu, mu, nu, nu, so these are all bound. Right, so you can do whatever you want, and it's really easy to tell, right? Is it repeated with one upstairs and one downstairs, therefore they're bound? Or is it an index just all on its lonesome? It's the only one of its kind. Although this is why we want to be careful. If I am adding, so these are just some tensor products I wrote down. If I wrote T sigma plus G sigma, these, I mean, again, there are more than one sigmas, so in that sense, they're repeated, but we're adding them together. These aren't repeated in a way that they're contracted or anything. So these are still, it's sort of like there's only one index and it's free. So this is still a free index. Right? There's no summing going on. So one other way to really think about this is there a sum going on or not? And that will help you distinguish. All right, so that's the basics for free versus bound indices.